Hello, everybody, and welcome to our, what month is it? October edition of our Akka.net community stand-up. I'm joined here with Gregorius Sodharmo. Sorry
Good
for
morning.
the slight delay on getting going. I had some technical difficulties with my webcam there, but we got that all resolved. Gregorius, how are you doing?
Pretty good. And how are you?
Good, good. No complaints. Ready to actually get some work done on real projects after this, since it feels like most of what I've been doing has been fixing CVEs and doing support issues lately. But you know what? Them's the breaks. Hassan, good to see you as well. All right. Well, I guess we should go ahead and dive straight into our agenda and talk a little bit about that. Rodrigo, good to see you too. All right, let's go ahead and bring my screen on stage here and go through our agenda. We've actually released quite a bit of things since last month. I'll go ahead and get rid of that. We're not really doing anything with Akka.net 2.0 right now. So let's kind of start in reverse chronological order here. Our first big thing we did is we basically improved a minor formatting bug with Phobos 2.10. We covered Phobos 2.10 a little bit in our last community stand-up, which introduced a whole bunch of really big metrics and improvements and totally reinvigorated dashboards. We have a video on our channel from the past 6 weeks or so where we kind of covered that. So that was a really this is kind of just a minor cleanup improvement in addition to that. Actually, you know what? I'm not using my banners here. Here we go. Recent Akka.net releases. And then we've done a number of Akka.net and Akka.Hosting and Akka.Management releases since as well. First thing we did, Gregorius, this was your fix with Akka.net. Whoops. Looks like we linked to the wrong thing there. This was really your big fix here, which is basically propagating errors from .NET's TLS handshake. A big theme you're going to see with today's whole community stand-up is transport layer security. That is definitely that, and Akka.Persistence health checks are probably the two big things we're going to touch on quite a bit. But this was kind of the first wave of bug fixes we did into ultimately discovering what was a pretty significant security vulnerability with our TLS implementation. So, Gregorius, correct me if I'm wrong, but the issue here was how we were listening, or rather not listening, to TLS validation errors from .NET, correct?
Correct. Yes. We assumed that everything would be raised via exceptions. Turns out they used callbacks instead. So we never actually captured them.
And they don't even properly propagate the failure callbacks. It's rather a user-defined event when something goes wrong with the basically if you inputted. So I think the way this got discovered is we had a paid support customer who reported that a node with an expired certificate was able to join their cluster, and they wanted to know how that happened. Well, this was this was the first wave of bug fixes that conversation produced, and there were at least two more after this that we'll keep getting into. But this was kind of the big release that went into 1.550. We also did, this was another one of your projects, Gregorius. If I go and pull this up. All right, looks like this all got hot linked to the wrong thing. But we had to upgrade our Kubernetes client for Akka.Discovery.Kubernetes to, I guess, version 17, because the older versions, which all targeted .NET 6 and newer, or sorry, maybe it was .NET 6 and older, all had some pretty significant vulnerabilities to find in them, which you can see here. Where basically the certificate validation logic would essentially accept things that didn't have a proper trust chain. So that got reported to us in Discord, and Gregorius, you patched it. And I think the big thing we had to do was drop .NET standard support for this plugin. Yeah, do you want to talk a bit about that?
Yeah, well, the way Kubernetes client works is that they follow Microsoft cadence. So they just, whenever there's a new .NET that came out, they just, move to it and drop the release, the support for the old ones. So in order for us to get rid of the CVE, which is only being fixed on the latest release, they didn't like backport it to their old versions. We have to bump our targets. Framework targets.
Yeah, we have to bump everything to the most recent long-term release, which is something, by the way, we should talk a bit about when we pivot over to our Akka.net 1.6 conversation today. Let's see, we bumped Akka.Hosting to 1.50. That was a pretty minor release. And then we have the next wave of TLS fixes here. This was just 7 days ago, basically, that we did this. So this particular issue was that even though we could detect invalid certificates and report the error now, we realized that we were basically not handling the handshake failures appropriately when there was a bad cert detected, and we needed to basically trigger a early process exit inside the system here, which I believe we do that now. So that was one set of failures, was trying to trigger failures. Now, there was yet another problem with this that we discovered a few days later, which is that these TLS handshake failures could only get detected on an inbound server that was receiving an inbound connection that had a bad certificate. Outbound clients that would still try to connect without having a valid private key could still successfully do that. So this only fixed 50% of the issue and didn't fix kind of the biggest security hole that this opened up, which we'll get to in a moment. The other big thing we introduced in this version here was, let me find it. That would be the persistence health check handling code. We're going to do a little demo of this in just a minute, but long story short, we incorporated into the Akka.Persistence base class. If I go and pull this up, if we take a look at, I guess it would be async write journal. We'll just scroll down here. We have a new virtual method that can be overridden and subclassed in other persistence plugins called check health async. And it returns a persistent health check result. And this data structure basically contains fields that are pretty comparable to what you'd see in Microsoft.extensions.health checks. So information about the last exception that was thrown, some tags and status information, that type of thing. The default health check implementation we have in the base class here is actually pretty solid. All Akka.Persistence implementations rely on a circuit breaker for being able to manage periods of persistent failure stemming from things like the database getting too busy or the database connectivity being somewhat spotty, that sort of thing. The circuit breaker will detect that and will change its state to half open potentially, or all the way open, which is pretty catastrophic. We decided to be kind of conservative on how we tailored the persistence health status here, where rather than returning a full-blown unhealthy result, which typically means the process needs to be restarted, we return degraded for both of these, which indicates that the health is not optimal, but it may not be necessary for a restart. So this is just trying to be a little bit more conservative with how we tell the health check system that's listening to health checks what to do with this process. So this is kind of the base health check implementation that's on the journal. We also have a corresponding one on the snapshot store as well. These two things are more or less mirror images of each other. And that was really something we decided would be easiest to kind of implement I think our default implementation in Akka.Persistence itself is probably good enough for all the other persistence implementations out there, but we left it open so it could be customized. So for instance, if Akka.Persistence SQL has the ability to call down to like a link to DB specific health check implementation, you could certainly do that and override that inside the journal or snapshot store base class implementation. And then we get to Akka.Hosting 1.5.51, where we introduced a persistence health check support, and we also added dependency injected health checks. I'll go and pull this up here. So this was contributed originally by another user. So let's see if I can find his stuff down here. Let's see. Amir. So he went ahead and he contributed this originally, and we just more or less kind of cleaned it up. Wow. This got referenced from a bunch of Dependabot pull requests everywhere. That's kind of funny, actually. But the gist of this, if we take a look at our documentation in the main Akka.Hosting repo, is if I go down to health checks, you can basically do a dependency injected health check where you implement the Akka health check interface, and you can accept basically constructor arguments that get DI'd by Microsoft.extensions here. And when this health check gets invoked, it'll go ahead and automatically populate all of these using the service provider. So that way, if you want to, I don't know, inject an I required actor, or if you want to inject another service from somewhere else and call that inside Akka.net, you can totally do that now. So that all works. And then on top of that, we have our persistence health checks, which I'll show off probably after we get through all of our releases. We had to do an Akka.Hosting 1.5.51 release here because apparently I forgot to negotiate around an early return. And so health check registration would only work on Akka.Persistence if you also added event adapters. Whoops. That was my fault. Found that when I was in the middle of configuring Akka.Persistence .Azure and Akka.Persistence SQL to actually use the health check implementations. So that was kind of a mistake on my part, but that's been fixed. And then we have our release from, I guess this would be Monday, Akka.net 1.5.52. So this is one of the big headline releases that we mentioned in the thumbnail and also in all the social media stuff. So long story short, we kept working with this customer who reported the TLS issues, and we released a total of 3 patches. And I think this one is probably going to be the last one we need to address it. But there was a fundamental design flaw in the way we implemented TLS inside Akka.net. Now, this basically comes down to me simply not knowing any better when we originally designed this back in like 2016. So it's a matter of just not having experience. We have been trying to implement, this is what we've been kind of advertising on our security documentation, which by the way, we also updated as part of this release. If I go and open this up here, this page has been rewritten here. But the basic gist of this is that Akka.Remote uses a peer-to-peer connectivity model. Every node is both a potential client and a potential server. Typically, when you're implementing transport layer security for something like a web application, you only really care about securing the identity of the server. All of the clients want to know the server they're working with is a trusted party. And that's what the whole root certificate system helps us do, validates the chain of trust, helps us ascertain the identity of the party, and helps ensure that there's no man-in-the-middle attacks. That is normally all you need to go ahead and build a secure web application. Things are a little different, though, in a peer-to-peer network. In a peer-to-peer network, it's not sufficient to validate the identity of just one party. You have to really validate the identity of both parties. And that's where implementing mTLS, otherwise known as mutual TLS, was really the correct fix here. Where what we needed to do was essentially change it such that during the Akka.Remote, or really it's the .NET sort of a pipeline, we need to basically make sure, if I go over to here, and let me see if I can find I think it's here. Yeah. What we needed to do is we have a new setting now, require mutual authentication. This basically is going to enforce certificate-based authentication. It means that the client and the server have both been keyed with the same private key, is what that means. So everyone has access to the same credentials. Everyone's all on the same network. We also made sure this worked with suppress validation, which means that you can suppress validation on the certificate. That means, if you want to use a self-signed certificate or something that doesn't use a root signing authority, you can still enable that if you want. But with mutual authentication, we still require you to get your password right and to actually present the matching private key on both sides of the handshake process. So we implemented this. This should now properly implement mutual TLS all the way through the entire code base. Now, the other thing we added as sort of a facet to this is Gregorius's fix that he originally introduced for validating the private key only worked when someone was trying to connect to you on an inbound connection. We changed it so now the private key actually gets validated at process start, and in the event that private key can't be authenticated or can't be found, we will immediately terminate the process during actor system boot. So that way, there's no possibility of being able to launch a process with a missing credential when TLS is enabled. So that's a big improvement there. And then finally, we should take a look at the CVE that we filed, which is under, if you go to the GitHub repository for Akka.net and go to security, go to advisories. This is the advisory we just published a couple days ago. This is remediated by Akka.net 1.5.52. So this should make its way through NuGet in the data there. In fact, I wonder if we take a look, if we go and pull up NuGet, if we take a look at Akka, oops, well, that's not how you spell it. Take a look at Akka.Remote. Let's see if there are any CVE. Yeah, here we go. All right. So the CVE data has already made it into NuGet, which is good. We appreciate that. The basic gist of this is that you need to upgrade Akka.net 1.5.52. If you do not upgrade to 1.5.52 and you're not using TLS, then you don't really have an issue. If you weren't using transport layer security before, this bug doesn't affect you at all. You're basically running with your network exactly as it was before. But if you were running with TLS and you expected it to be mutual to basically enforce certificate-based authentication, only Akka.net versions 1.5.52 and newer enforce that properly. So you should upgrade to that version. So that's kind of the gist of all the security stuff around TLS that we've done over the past week or so. Gregorius, did I miss anything important in the context of all that?
No, I think you got it all.
Okay, good. So, we it took us a few stabs to kind of get a solution that we were fully satisfied with. But I think this is reasonably good. We have made mutual TLS enabled by default. You actually can opt out of it if you want to. There's a setting you can use to disable it inside Akka.Remote. I would probably not do that. I'd probably leave it on. But if there was a scenario where you wanted clients to be able to connect using only the public key, which is basically what like a web client would do, Akka.Remote fully supports that still. Okay, so that's that for all the security patch stuff. I won't bother going into this. I spent a fair amount of time this weekend trying to eliminate race conditions from most of the Akka.net test suite. I think I got about 15 pull requests merged as part of that effort there. Mostly just trying to get our flip rate on our test suite down as close to 0 as I can. Not because this provides any particular business value, but because it means that people start ignoring legitimate failures that show up in the test suite as a result of the noisiness it produces here. I guess the other thing I should mention is that we actually did find a bunch of legitimate bugs inside Akka.Streams and inside Akka.Persistence that have all been fixed as a result of this. They tended to be fairly minor things. Those all should get shipped in the 1.6 beta that we are working on, which brings me to our future Akka.net plans here. Let me go ahead and pull that up. Let's see. Akka.net 1.6. We have been long overdue on getting a beta of 1.6 out the door. Here is how I am feeling about that. On Friday, we are going to be celebrating an important milestone. Akka.net just crossed, if you take a look at NuGet. We actually did this maybe a couple of weeks ago, maybe 10 days ago. We crossed 100 million downloads from the entire NuGet organization. And that runs the gamut from all of our core plugins, which I think these are all sorted in descending order of install count. That includes all of our core plugins, some of our other stuff like Hyperion, but it's mostly all the big Akka.net plugins is where all these download counts all come from originally, which is great. That's a huge achievement and a milestone. At our live stream on Friday that we're going to go ahead and do, so we're going to spend 3 hours implementing a feature from Akka.net. Based on the voting that came in, it looks like I'm going to be rounding out AOT support for Akka.net, which is great because that's the feature I actually personally want to use. Quickly. So I think we will probably do a beta release of Akka.net 1.6 as early as next week, depending on how much stuff we get done here. Gregorius, if I hadn't communicated this earlier, you're going to be doing me. No eggnog this time, though. Yeah. And if you missed that reference, that was due to Was that just a Christmas stream or like a holiday stream
Yes,
we did last year? Okay, I was trying
it
to
was
think
a
if we.
Christmas stream.
All right, I was trying to remember if we did anything specific. I know we had one user complain that we played. What's that song? It's like Dance of the Sugar Plum Fairies nonstop in the background. It was driving people nuts. I personally drank a copious amount of eggnog to a point where I was not feeling well later that day. We will not be doing that, but I think Gregorius and I will be speed running AOT support, which should be cool. So we're going to go ahead and try to do that on our stream on Friday and hopefully get our first release of Akka.net 1.6 out the door then. Gregorius, on the 1.6 and 1.5 Akka.net front, I guess, you know what? You and I were going to spend some time talking about this, dropping .NET Standard 2.0 support and changing our target runtimes, right? All right.
Yep.
Akka.net 1.6 is going to be a performance-focused release. One of the pieces of baggage we are going to need to shed is support for .NET Framework. The reason why that is that our new Akka.Remote transport that we want to implement, which is based off of Microsoft's Quick implementation, is something that I don't think will ever be ported to .NET Framework. So it's a bit of a non-starter from that perspective. We are going to announce some plans for sort of extending support of Akka.net 1.5 for people who are running on .NET Framework. That's something that we will basically expect an announcement on that at some point in the near future. We have plans on doing that because we do know we have a big community of people who are running .NET Framework for production workloads today. So we don't want to leave them huddling out in the cold. But in the name of being able to achieve higher performance, we're going to go ahead and basically kind of follow the same sorts of cadences that Microsoft does on their releases going forward foreseeably. So that means using the latest long-term .NET candidate in perpetuity going forward. Did I get that right?
Yeah.
Yeah.
I think so.
Okay. So we the Akka.net 1.6 beta probably won't introduce this yet, but it won't be long before we do begin introducing that. And then I think for our show and tell today, let me go ahead and pull up a little banner here. We're going to go ahead and take a look at the Akka.Persistence health checks. So the code sample that I'm going to pull up here, if I go to the Pettibridge organization, is drawtogether.net. So I'm actually working on, looks like I had a racy unit test failure there. I'm actually working on a new pull request for this right now because I just upgraded to the most recent version of Akka.Persistence SQL and Akka.Hosting. But I wanted to show you basically how easy it is to go and work with the new persistence health checks. So this is the newest version of Akka.Persistence.SQL. And you'll see down here, if I go and get rid of this, this is sort of what a normal call to organize SQL persistence for both your journal and your snapshot store using SQL Server looks like. Not terribly complicated. Well, if you go and use the journal builder, which is a construct that we've historically had for being able to add event adapters and that type of thing, you can now call with health check, and you could customize it if you wanted to. You could say, I don't know, go ahead and say description. Actually, what are the little fields here? Yeah, I can basically check what the unhealthy status is. I can set the name. We'll go ahead and call this Akka.Persistence.SQL default if I wanted to. And then we added another parameter right here, the snapshot builder. And this is new. This is part of the new Akka.Hosting API. It's what snapshot builder with health check name. Yeah, there we go. Akka.Persistence SQL. Right, let me go and change this to journal. And we'll call this snapshot default like that. That looks pretty good. All right, this should enable the health checks to actually go and hit the real underlying implementations here. Let me just make sure I have Docker up and running. Okay, looks like I do. So we'll go ahead and build and compile this, and I'll check the health check endpoint, and you should see it all working. All right, that might take a little second here. I think we are running, Health Z is our endpoint that we're exposing. So we're going to launch .NET Aspire here. Give that just a second or two to kind of launch all the Docker containers and get the runtime up and running. There we go. Pull this up. Okay. Here's .NET Aspire. Go ahead and reload that. It actually has to get Azurite and draw together. I'll draw together this database and a couple other dependencies up and running. So we'll give it a chance to do that. Hopefully I didn't torch SQL Server. It's going to run our database migrations. Let's go and check on the progress there. All right, looks like that's done. And looks like all of our services are up and running. Grand. This is all going to go ahead and just compile Blazor server real quick. Get all that working. Hopefully. All right, there we go. Looks like that's all working now. So we've JIT compiled everything. And if I go to Health Z on this endpoint down here, you can go ahead and see our health checks, and voila. Here are our Akka.Persistence SQL Journal and Snapshot Store health checks. So these are taking a look at the underlying circuit breaker the Akka.Persistence SQL is using and are returning whether or not that health check is passing, essentially. And we can see here that everything is being reported as healthy. If I went and took down, in fact, this might be a fun demo. Let me go to my containers here. Actually, I could do this in the Aspire window. Let's go ahead and shut down the SQL Server instance. Go ahead and turn that off. And actually, you know what? Funnily enough, that health check won't fail until I actually try to resolve something. Because of the way Akka.Persistence works. It only fails after it started observing real underlying failures from the health check system. Let me go ahead and hit this again too while I'm at it. See what happens there. Yes, it looks healthy to me. Well, I would need to log in and actually try to run some traffic over here, which I'm not going to do just because that would take a little bit of time to do. But that would cause some underlying failures to occur, and you would see these health checks eventually start to degrade, reporting a degraded status back. So the Akka.Persistence plugins that we've added health checks to so far include Akka.Persistence SQL and Akka.Persistence Azure. We will also add them to MongoDB and Redis in the not too distant future as well. So I think with all that being said, I think that will do it for this month's community stand-up. We will see all of you on Friday at our 100 million Akka.net download live stream. I don't think no eggnog this time, but it should still be a good time. We're going to try to speed run introducing AOT support for Akka.net. Oh, there we go. We're starting to get some failures back now. Let's take a look at this. Yeah, see, thank you, Aspire, for bailing me out. I can actually go ahead and see it's showing me the formatted logs here. Yeah, we can basically see that, the Akka.Persistence health check stuff are all starting to fail, which is good. Health check name, application DB context. It's actually the entity framework ones. That's probably because it's evaluating the underlying data connection, not looking at the actual operation succeeding and failing. All right, Gregorius. Well, I think we did it. And everyone, we will catch you on Friday at our 100 million install extravaganza. Thank you very much.